Good morning, everybody. Welcome to my talk on Eigenda, Eigen Data Availability System, built on EigenLayer. I'm going to talk about how to build hyperscale applications on Ethereum. Awesome. So let's start with something pretty basic. Let's look at the landscape of how applications are today, and there are really two dimensions to this. So you can think of two dimensions to measure the performance of applications. The first dimension is throughput, which all of us think a lot about. When you want to build new games, other kinds of interesting things, social, all these things, you want to think about what is the throughput. But there is another equally important dimension that we need to think about when you're building high-performance applications on Ethereum. And one way we like to think about this is what I call value per bit. What is value per bit? Imagine you're doing a transaction on Uniswap, or buying a Bored Ape on your favorite, OpenSea or whatever other NFT marketplace that you use. You're transacting something worth $100,000, but it takes like a 200 byte transaction. So you're essentially transacting like $1,000 per byte. So that's what we call value per bit. So what this means is when you look at what the value per bit of the applications that are being built today, they're actually pretty high, right? High value applications are well suited for blockchains. But if you look at where we want to be, we need to enable low value per bit applications, right? Like gaming, social network, all these kinds of things. If you think about something like Twitter, you have like a huge Twitter thread, and how much value is it? At least, most of the Twitter threads are not worth anything. So you have this kind of like a very low value per bit and very high throughput. But the important thing is the core performance metric is the product of these two things. Value per bit times bits per second is value per second. So actually you can make up for the low value in actually creating high volume. And so one of the fundamental problems here is that the cost per bit, the cost required to transact these transactions, should be much lower than the value per bit. Otherwise, it's not going to be able to transact these kinds of interesting applications. So how do we actually think about the cost contributors to a blockchain? Number one is the capital cost. If you want $1 billion stake, you want $1 billion of economic security, that means you want $1 billion stake. That's the cost of capital. There is an operating cost. If you're running a system and there are hundreds of thousands of nodes, in Ethereum there are 500,000 virtual nodes running the system, they all need to download and store this data. There's an operating cost relative to it. And then finally, there is a congestion cost. If you look at all blockchains today, like if you know Ethereum EIP 1559, it's pricing for congestion. The more the block gets filled, the higher the price it is. So these are three contributors to the cost. And how do we actually shave them down to the fundamental limits so we can actually start building super high performance applications on Ethereum? Number one, to reduce the capital cost, we use shared security. What does it mean? We have this primitive called EigenLayer. EigenLayer is a mechanism to share security between the Ethereum core protocol and any other applications built on top. Since the same stake is used on all these applications, you get cost reductions in capital cost. How do we reduce the operating costs? We reduce the operating costs by actually building better systems. Every node should not have to download and store the data. And then finally, we reduce the congestion costs by creating high throughput in the system so there is no congestion. In fact, you should be able to go and reserve your block space, just like you go reserve on Amazon a node that you want to use. Okay, so I think I'm going to assume we're all familiar with the roll-up architecture. The idea is you offload the computation, but you still have to publish the data, and publishing data is very expensive on Ethereum. So if you think about what properties we need from a system for publishing data, here are the few properties. You want it to be hyperscale. What is hyperscale? Hyperscale is very high performance. You want the throughput of the system to scale as you have more and more nodes in the system. So if there are n nodes, the performance should increase as the number of nodes increases. It should be low cost. It should not cost as much as downloading and storing data on tens of thousands of nodes. That'll make the system very expensive. You want the cost to be as low as roughly like a single node downloading and storing data. You want low latency. You want verifiability. Verifiability is you're running a system, you want nodes from the outside to be able to actually verify that your system's doing the right thing. You want hyper customizability. You want to say, hey, if somebody's running this data system, what is being staked? What is the erasure code being used? What token is the fee paid in? You want customizability in all these dimensions. EigenDA, Eigen Data Availability System, is the first system that achieves all these 5 properties. It's a system designed from first principles to be an adjacent data availability layer for Ethereum, which actually gets you to the fundamental limits of all these properties. So powering all of this is EigenLayer. What is EigenLayer? Eigen in German for your own, layer. You can build your own layer on top of the Ethereum Trust Network using EigenLayer. How does it work? You stake in Ethereum. When you stake in Ethereum, you're putting down ETH and promising that you will hold to the validation conditions of Ethereum. What EigenLayer lets you do is to opt in to not only promise to serve Ethereum block production correctly, but arbitrary new systems, new chains, new oracles, new data availability layers, bridges, game execution environments, all kinds of interesting things can be built on top of the common trust network that is Ethereum. So if somebody wants to build a new kind of a middleware or a service, what they're building is an off-chain container, which can be arbitrary code run by the node, as well as a smart contract, which talks to the EigenLayer contracts. EigenLayer itself is just a system of smart contracts on Ethereum. Talk to the EigenLayer contracts and then promises that the staker opts in to promise that they're going to opt in to run your new system. And if they don't do it correctly, they can lose their ETH. So that's how the trust is transferred from Ethereum through EigenLayer to any new system that can then be built on top. Awesome. So how does EigenDA work? EigenDA is, again, an adjacent data availability system to Ethereum. You want to build your rollup on top of Ethereum, and you want to know how to scale the data performance on Ethereum. Today, Ethereum's data availability throughput is extremely low. It's 80 kilobytes per second. And at 80 kilobytes per second, you can do very important, high-value financial applications. You cannot run your games, you cannot run your social, you cannot run your Twitter, you cannot run all the interesting things that we were promised we can do in crypto. So that's what EigenDA is built to enable as an adjacent to the Ethereum network. How does EigenDA work? Essentially what you have is, when you're building a rollup, you have this notion of a sequencer that takes all the transactions, orders them, and then updates the state. When we're thinking about the sequencer, what we give is an adjacent code base to the sequencer that lets you talk to the EigenDA system. EigenDA, there's a bunch of nodes running EigenDA. Who are these nodes? They're Ethereum restakers. Ethereum stakers opt in and promise to run this data availability system. That's who's running EigenDA. Take the data, use an erasure code, and you take a huge data blob, right, whichever, the sequencer usually writes this to Ethereum, which is very expensive. Instead, it takes the data blob, performs an erasure coding, and then sends this data blob into small chunks, and sends these chunks to each of the EigenDA nodes. Each of the EigenDA nodes receives only a very, very small chunk. If there are n nodes, it's only 1/n of the size. If you have a 1 gigabyte file and there are 10,000 nodes, each node is downloading something like 0.1 megabyte, so far smaller than the original data size. So they do this, and then they can verify that they got the right chunks, and they sign off using BLS aggregate signatures. They sign off using their signatures, send it back to the node, which aggregates all these signatures and sends it back to Ethereum to the EigenDA contracts. Aggregates all the signatures. On Ethereum, now it's verifiable that EigenDA has done its job, stored the data, and then issued the certificate. So now you have the certificate on EigenDA contracts on Ethereum. Now your rollup can make progress to the next step. So that's the whole idea of the EigenDA system. It's built purely as an adjacent to the Ethereum system. So fundamentally, many different trade-offs that you have to make in order to build the system. And that's how we achieve all these different performance metrics. One way to think about this is actually looking at the comparison of what we are able to achieve with the system. So let's look at the throughput. The throughput of the system, I mentioned Ethereum is at 83 kilobytes per second. With dark sharding over the next 3 to 4 years, there's a roadmap to go from 83 kilobytes per second to 1.3 megabytes per second on Ethereum. EigenDA is built on some of the core ideas from Dangsharing, but is actually far higher throughput. It's because it's not designed to do all the things that Ethereum is doing, which is things like consensus. It only does data availability. By doing this, it's actually able to optimize for all these performance. The system's running at 10 megabytes per second. We're not doing scaling in the same way Solana, for example, is doing scaling by having beefy nodes. Instead, each node does a little bit, but together, the system does a lot. So each node only needs to download 0.2 megabytes per second, but the system runs at 10 megabytes per second. So that's why we call the system hyperscale. We have a roadmap to scale this from 10 megabytes per second in the next 4 years to 1000x from where we are today. So there is a lot of scaling further to be obtained. It's highly customizable. It's very low cost. It transforms the economics of how you build rollups. If you look at rollups today, they're not really compatible or competitive with the layer ones. Why is that? There are 3 factors. Number one, almost all of the cost in the rollups today are going to data availability. The data availability cost is high. Okay, and today, most of the rollup cost is going to data availability. Not only the cost is high, the cost is uncertain. Today the cost is X. In next 3 days, the cost may shoot up to 10X. This uncertainty is too difficult for rollups to handle. Finally, rollups cannot pay in a fixed fraction of their native token. Imagine you're running a layer 1. If you run your own layer 1 like an app chain, what you could do is you could just say that I'm paying 2% of my inflation or 5% or 10% of your inflation to your stakers. You have a fixed fraction of your inflation that you need to pay. But that's not the case with rollups. They're paying in hard ETH. And they take exchange rate risk from their rollup native token to Ethereum. EigenDA transforms all of this and makes rollups far more competitive than building your own layer 1. How is this? So the first one is data availability cost is really low. Why is it low? It's low because of the reasons I laid out earlier. No capital cost because capital is shared with Ethereum staking. No low operating cost because every node downloads very little. So the DA cost is actually very low. Not only that, the data availability cost is not uncertain. You can reserve for data availability. Imagine you're building a game rollup. You want to go tell your users that till this much amount of transactions, it's free. You can't do that with the rollup economy today because you're paying in hard cash, in ETH, to the Ethereum system. Whereas with EigenDA, you can actually go and reserve for your data bandwidth for the next year. So what this means is you have your guaranteed data lane. Yuga Labs does a Bored Ape drop and your price shoots up. No, it doesn't shoot up. You have your own reservation. You have your own slot. You have your own data bandwidth. That's what EigenDA does. And finally, you can actually pay DA fees in your own native token. Imagine you're building a game, a social, all these kinds of interesting applications. One of the things you want is alignment with the Ethereum community. You can actually pay in your own token. So each stakers receive fee, not in ETH, but actually in your own native token. So all of these fundamentally make rollups built on EigenDA extremely cost competitive. In fact, much better in economy of scale compared to go and building your own rollup, your own chain. Beyond EigenDA, Ethereum actually, EigenLayer transforms the modular Ethereum landscape. Lots of limitations that you have today can be removed using EigenLayer. So if you integrate with EigenDA, as these new features start coming up, you can actually use them. I highlighted already that data bandwidth issue. Finalization time is too slow. You can actually build super fast settlement on Ethereum using EigenLayer. Many teams are working on many of these things. You can reduce the censorship resistance risk using decentralized sequencers. Espresso is building a decentralized sequencing system on EigenLayer, so you can get super fast liveness. There are latency issues when you bridge from one rollup to the other. There are a bunch of bridges building on EigenLayer which actually give you super fast bridging across rollups. Finally, managing MEV, which is ordering freedom, is actually possible using EigenLayer. There is a bunch of new MEV solutions coming up. So what I want to say is EigenLayer is a great complement to the modular Ethereum roadmap. It lets people build new features that can then be utilized by rollup builders to solve the core problems that we're facing today. Thank you so much. You can find more information on our website here.